So, let's go through our lesson for today. It's going to be really easy. So we did this yesterday, right? We went from an exponential form into a radical form, right? We went from having an exponent to having a radical. We did that yesterday. We all agree?
Yeah.
Yeah. Today we're going the opposite way. It's even easier. We're going from radical form to exponential form. It's important you know what each of those means. Exponential form, radical form. They're pretty self-explanatory, right? Exponential form has an exponent, radical form has a radical. So, yesterday we went this way, now we're coming back this way. Where our power will become our numerator, our root will become our denominator. Now, you have a bunch of fill-in-the-blanks, they're all right there, they were there. The first one, like I just said, the index or the root is going to become the denominator of the fractional exponent, or our rational exponent, however you want to say it. The power from our radical will become the numerator of the fractional or the rational exponent. So fill your blanks in really quickly. We'll do a couple special cases, and then we'll just do a lot of practice.
A lot of homework?
Okay? What?
How many problems is there in the homework?
1.5 million.
I have a game in it, so that's
That
not
sucks,
okay.
man.
I know.
Good thing we're gonna have a lot of work time if we just do our notes and not get sidetracked. Okay, we got our blanks filled in? Yes, all right. So like here. Okay, so a couple special cases. So we talked about this a little bit yesterday too. I really don't consider them special cases. The only reason they're considered special cases is because they don't have both parts to them. This is a square root, right?
Yep.
What root is that? The second root, right? The second root. This x doesn't have a power with it, but what's the actual power?
1.
1. So if I was going to change it to an exponential form or a fractional exponent, it's going to become x to the 1/2 because the power becomes the numerator, root becomes the denominator. So it's a special case because it's missing the actual numbers. Just like the second one, it's the third root of x.
Oh, I got this
Well,
one.
that's x to the first, so
X to the third.
x to the 1/3.
Yep.
Careful, don't say x to the third, that means x to the third power. X to the 1/3. Okay. Any questions about the special cases?
Oh dear, that's a lot.
Sweet. Let's do all of our problems really quickly.
What?
A lot of them. We're going to do a lot of these examples really quickly, okay? So the first one, the square root of x cubed. Well, we said the square root has a root of 2. So it should become x to the 3/2, right? My power becomes my numerator, my root becomes my denominator. So it's x to the 3/2. The second one, the fifth root of x to the third power. Well, my power is my numerator, whether it's underneath the radical or outside, and my root is my denominator, so it's the fifth, 3/5. Does that make sense? Pretty easy? Okay, let's keep going.
Alright.
The cube root of x squared, well, becomes x to the 2/3. Power becomes my numerator, root becomes my denominator. Same thing. The sixth root of x to the 5th. Well, x to the 5/6. Power becomes the numerator, root becomes the denominator. Cube root of x to the 4th, x to the 4/3. Power becomes the numerator, root becomes the denominator. Sixth root of x to the 7th, x to the 7/6. Power becomes the numerator, root becomes the denominator. Last two down here, the square root, so the second root becomes x to the 5/2. Square root of x to the 9th becomes x to the 9/2. Okay? Does that make sense so far? A little bit easier than stuff we did yesterday. It's literally the same thing, we're just going the opposite way. So we should be able to go both ways with this. Okay? Alright. Now it says reduce if necessary. If you can reduce, it is necessary to do so. Alright, so anytime we can reduce a fractional exponent or a rational exponent, we are going to do so. So look at the first one. X to the 8/4, right? Power becomes the numerator, root becomes the denominator. What is 8/4 the same as? 2. So it equals x squared. That should be your answer. If you don't reduce it, and it's on a test, what do you think is going to happen?
Fail.
Get me wrong. Okay? If you put 2/1, is that okay?
No.
That's fine with me. If you want to put 2/1, I'm perfectly okay with that. If you're gonna put x squared, I'm okay with that as well. All right?
You sure?
4th root of x to the 6th. X to the 6 fourths. Right? I can reduce that to x to the 3 halves. That's my answer. Looking at our next one, it's the square root of x to the 6th. X to the 6 halves, or x cubed. The square root of x to the 4th. X to the 4 halves, which equals x squared. If I'm going too fast, you want me to stop, just let me know. X to the 6 thirds equals x squared. X to the 12 thirds reduces to x to the 4th. Right? Root becomes a denominator, power becomes a numerator. X to the 10 fifths equals x squared. X to the 5 tenths becomes x to the 1 half. X to the 9 thirds becomes x cubed. X to the 9 over 9. What's 9 over 9? 1. So x to the first power. Is it okay to write as x to the first power? Yeah, what else could you write it as?
X.
Just x, right? That's fine. Alright. The 4th root of x squared. X to the 2 fourths, which is x to the 1 half. X to the 2 sixths, which is
1/3.
x to the 1/3. Last two down here. The square root of x to the 4th, so x to the 4 halves, which is x squared. Square root of x to the 8th, x to the 8 halves, which is x to the 4th. Okay? Any questions on those? I know I ran through them really quickly, but I figured you guys picked up on it really quickly. Do you have any questions? Alright, I think there's 3, like we did yesterday. I want you to try those 3. I'll put my answers up in a second. But now that we've done it both ways, hopefully it's a little bit easier for you the way we did it yesterday. So I want you guys to try those 3, if you have not already. Once you've done them, check your answers at mine. Did we get them right? Yeah. Guys, one thing I want to be really particular about, last hour I had some people do this, and I want to make sure it doesn't happen. If we look at the second one, this is our answer, right? Is that the same as that? No, right? That means 5 times the square root of x to the 4th. You need to be really careful when you're writing these. That 5 needs to be in the root spot. It needs to be inside there. Alright? Do not put it in front. That does not mean the same thing. Okay, I'm glad we're on the same page there. Alright, anyway, what? 3 problems left and we're done?
Yeah.
Sweet. Alright, write in simplest radical form, aka using only one radical sign. Well, the first one I have w to the 1/8 times w to the 3/8. What should I do first? Simplify it, right? Use exponent rules to simplify first. So my exponent rule here, I'm multiplying things at the same bases. What did you do there, exponents? Add them. What's 1/8 plus 3/8?
4/8.
4/8. Now, I'm not going to change it to a radical there. I'm going to reduce that fraction first. We should get w to the 1/2, which then as a radical should be the square root of w. Or the second root of w to the first power, if you want to write it like that. That's fine as well. Okay? The second one here, h to the 1/6 raised to the 2/3 power. Now we have a power to a power. What do we do when we have a power to a power? We multiply them, right? 1/6 times 2/3. Hey, guys, how do we multiply fractions?
We're making them the same.
We're not making them the same. We're not adding. If we're adding, we want at least common denominator.
Cross.
We just multiply tops, multiply bottoms, multiply it straight across. Right? 1 times 2 is going to be 2. 6 times 3 is going to be 18. So that equals h to the 1/9, which as a radical then would be the 9th root of h. Okay? Uno más.
What?
Uno más.
One more. What's that mean?
One more. Down here, we have a product with powers to a power. What am I going to do with that exponent, that 1/4? So to the d. Distribute it. And we're going to multiply any exponents that we get together here. So we get y to the 1/4 times z to the 8/4. What's 8/4? 2. So y to the 1/4 times z squared. Am I going to change this to a radical? What about this one? Yeah. That becomes the 4th root of y, and then times z squared. But you need to be very careful. Make sure that z squared does not sneak under the radical. It is not in any sort of radical. There's no fractional exponent there. If you want, you can put z squared in front times the 4th root of y. That'd be perfectly fine. But make sure it does not sneak under the radical. All right, any questions?
No.
The color of what sheet?